take your time when we're doing these problems. So we're talking about rational functions. You have not learned any of this, I believe, in the past. So this will be brand new information, whereas last chapter you spent a whole unit on factoring. This chapter, I'm like 90% sure that you guys did not do anything with discontinuities and rational functions. If you remember back when we were talking about it in chapter 6 and 7, I told you guys there's going to be a point where you're going to see a hole, or you're going to see this thing called an asymptote. That's now where we're at. We're at that point where we're going to start seeing that discontinuity. So let's talk about it. The first part is just kind of like the wording of things. So rational functions is going to be any function that can be written as a ratio. So think rational ratio. Okay, ratio is like a fraction. Okay, so anything that can be written as a fraction or a ratio is going to be a rational function. So for example, something like x squared plus 1 over x minus 1. You see how it's a ratio. Okay. Technically, like, you don't have to write this down, but if you had x, that could be rational because you could write it like this. Okay, so it could look like that, but most importantly, you need to know that there's some things that don't qualify as a rational. Things like 3 to the x power. I'm going to circle that. Because of the x in the exponent, that's not rational. It's actually called an exponential function, which we will talk about next semester. Do you guys do in science class like exponential growth and decay?
I don't have a science class.
Like last year, growth and decay at all? I think you might have, like with like, yeah, I might have in physical science.
Physical science.
Yeah.
It's not earth science.
It's where like if you take like a medication, how long does it take for you to get it out of your body? That we're gonna get into that in math class next semester. It's actually more fun, I think, in math than it is in science. I'm not gonna lie. Okay, another one that would not qualify. There's only 2 that won't qualify. Is something like a radical 3x. Let's just say that. So if you see a radical or an exponent, that's not a rational function. Those are irrational. Well, one of them is. Okay, so those 2 things would say, I'm not rational if you saw either one of them. Okay? So, a discontinuity. I want you to highlight the letter D. Okay, discontinuity is a place where the function's undefined. Undefined. Now, what would make a fraction not defined? Does anyone know? What would make, let's just say I put a random fraction here and put 2 little circles. You don't have to put this down. Is there something that I can't have in either of those? Does anyone know? Like, is there a number that can't go in either one of those spots? Does anyone know from previous years? Yeah, what would be something if you typed in the calculator right now, it would tell you it's undefined? A 0. So 0 is correct. Do you know where the 0 can't be?
The top.
The bottom. Okay, so
You can have a smaller number above a big number.
you can have like 2/5. I ate 2 slices of 5 pizzas. But you can't have 0. You can't divide. Right now, take out your calculator and do 5 divided by 0. You're going to see that it's undefined. You can't divide things by 0. 0 is not something that has a number. Doesn't have like any kind of substance to it. I can't do 5 divided by 0. 0 is not anything. Okay, so that's kind of why it's undefined. So the bottom of our fraction cannot be 0. Is kind of where I was leading to there. And the reason why I highlighted D is because denominator. The denominator can't be 0. That's what the discontinuity means. So the D's go together to help you out. Does anyone know? It's like a random question here. Maybe I can give you a prize for this one. Do you know where on the graph, if this top number was 0, that would be? So what I mean by is, let me just draw this out really quick. If this was 0 on top, what would that be considered? Does anyone know? Like 0 on the bottom is undefined, but a 0 on the top means something in our graph. What? It is defined, but so it's defined where? Does anyone know if there's a 0 up here, where on this graph I would have a point?
At 1.
Right in the middle.
That's the origin. It could be there.
On top.
On the top.
Like right there, like the line.
Well, if you put the 0 on the top.
I heard
then
something.
you
I
have
heard
one.
I heard the word. Someone said it. What is this called? The x-axis. Your 0. So what you found in your bell ringer is basically what those are. They're the zeros. So whatever makes this 0 up here are your x-intercepts. I was just trying to going off on the side. You did not have to know that for this lesson, but just something random. Okay, I think you guys are going to be actually really good at this because yesterday you practiced solving. This part is the easiest of the chapter right here. So all you're doing is determining your discontinuities. So your eyes need to go right to the bottom. So discontinuities mean denominator, so go right to the bottom. Don't even look at the top right now. So I'm going to highlight the bottom of this first one. What makes 4x equal to 0? What number would I plug into x to get 0? 0. And I'm going to show you how to do that every time if you get stuck. You do 4x equals 0. You're just taking the denominator and setting it equal to 0. What would I do to both sides to solve like you did yesterday? I would divide. Very good. And that's why I get x equals 0. But remember, it's a discontinuity. So I'm actually going to write it as x can't be 0 because it does not exist there. Okay, so really you're just solving when you're finding the discontinuity. So let's do it again. Some of you will probably be able to do it without even solving. Like in your head, what would I plug into this spot right here to make the bottom 0? What number? A positive 2. Very good. Do you see how if I put a 2 right here, I'm going to get 0. 2 minus 2. But if you did not remember that, you could go ahead and set it equal to 0 so you don't forget. I would add 2 to both sides. And that's why I get a positive 2. Okay?
Why is it always equal to 0?
Because you're trying to find, if you have 0 on the bottom, it doesn't exist. And that's what you're trying to find. Where are we going to have a hole? Where are we going to have this thing called an asymptote, which we'll learn soon. So this is kind of what I was saying in my other class was, I'm trying to look for my gate, there it is. So for example, like if you got sick one year, you run a business and you just shut down because you can't run a business at that year. That's what you're kind of talking about. Like here's your graph and you're making all this money, but then all of a sudden like there's a hole there. What does that hole represent? That represents me being out for a year because I was sick. Okay, that's why we have things called holes and discontinuities, so that when you describe it to businesses and things like that, you'll be able to see where that hole is, that kind of thing, on your graph. All right, so let's do it again. Oopsies. Again, you could probably just look at this. What number would I plug into here to get 0? What number would I plug into right here to get 0? 12 minus what number gets me 0? A positive 12. Very good. So let's set it up so you can see it. If you get stuck, you just take the bottom and you set it equal. You're just solving. Some people will be able just to tell me it's 12. Some people might have to set it up. It's totally up to you. So what I do to both sides here, it's kind of tricky on this kind of one. Remember, my goal is to get x alone.
Minus 12.
You get minus 12. Do you see something that's actually easier? Definitely minus 12. I'll just do the minus 12. Minus 12. I get negative x equals negative 12. Now what? When I solve. How do I get x alone? What do I divide by? Yeah, negative 1. So x is 12. Or you could have just said, hey, if I plug in 12 here, I know I'm going to get 0. Either one works. It just depends on how your brain works. What I meant by something that could have been easier here, I'm going to do this in red just so you can see the difference. If you would have just added x to the side, you would have had your answer. Do the next one. Do this one. Actually, you know what? Let's do this one together, and then I have a task for you. So what makes this guy in orange equal to 0? What would I have to do to both sides when I set it equal to 0 here? You guys struggle with one-step equations? How do I solve for x? Yeah, thank you. I just minus 5. And that's my answer. Okay. So here's what I want you to do with yourself or a partner or your group. These ones are exactly the same as the one above it, if you notice. All right, you guys did really good. Anyone not get checked that wants to? Okay, so you guys did very, very well. Good job. Let's move on to 9 and 10. Remember, you're setting them equal to 0. Same thing. Don't overcomplicate this. So I'm taking this piece, 2x plus 6, and I'm setting it equal to 0. These ones are not as easy as the ones above it that you can't just like figure it out, but you can easily solve it. It's a two-step equation. You guys are good at that. What? Yeah.
So probably minus 6.
Mm-hmm.
Minus 6. That would be 2x equals negative 6. And then multiply by 2x. Multiply by, divide, right?
Thank you. Yeah, divide by 2.
And then, so it's going to be negative 12.
6 divided by 2?
12.
Divided.
What am I
6 divided by 2. It is 3, yeah.
Oh.
Okay. Do you have questions on how I just did that?
No.
Okay, then do number 11 because it's the same exact way. So I did 9, you do 11. See, the 2 is harder than the 1. What do you mean? The 2 is so much harder than only the 1. You're just looking at the bottom. You're not looking at the top. Remember, your eyes should go right to the bottom. You should not look at the top right now. Only the bottom. You should have got negative 3 again.
So the top wait.
What?
I wanted a ticket. I was looking at my calculator. I want to use Desmond.
As long as you have the work, I'm good.
Yeah, I just didn't have an answer. How do you divide negative 9?
Just think what's 9 divided by 3. Don't think about the negative. Okay, do you have a question on that one? This one, though, is super important because this is the ones that you're going to be seeing the most of. Again, I'm highlighting the bottom. This is what you did for the bell ringer. How do I factor this?
Square root.
Yeah, and I get x plus something and x minus something. What do I get? Because what's the square root of 16? Good, 4.
Oh, wow, I did that.
Okay, so we're factoring. We have to factor. We're going to put a note there. I have to factor. That's why we had that as a bell ringer, to get you ready for it. Now, with my 2 different color highlighters, I have to highlight one of them and highlight the other and treat them separately. What makes this yellow group equal to 0? What number would I have to plug in here to equal to 0? Negative 4. Very good. Or you can set it up like we normally do. But this time you're going to have to do it to both of them. That's the only difference, is that you have to set them equal to 0. This is what we did in the bell ringer, exactly what we did in the bell ringer. So what about this yellow group? What would I have to do to both sides? What would I have to do to both sides here? How would I get the 4 to the right side? Subtract it. That's gone. That's one of them. And how do I get this one over? I already just told you. Add it. Okay, so what does that mean? That means that I can't have 4 or negative 4 when I have to solve or when I'm doing this kind of function. On my graph, if you were to plug it in your graphing calculator right now, you would see that at these two numbers, it will say undefined. And you'll see this weird look shaped graph, which we will do tomorrow, but it's kind of cool. Like, think about how advanced you guys are right now. It's kind of awesome. So do 12, because it's the same exact thing. The first step is going to be, so I'm going to put first step, factor. What are you going to get on the bottom? Okay, so I'll give you a ticket if you get it right. Do number 12. Same thing as the one we just did.
Yeah.
Good job. Okay. So you should have gotten x plus 5 and x minus 5, and then you would get your final answers are plus and minus 5. Now there's an alternate way that I'm going to quickly show you for like 30 seconds how to do it if you're someone that's just pretty good with solving. Some of you would rather factor it, but I'm just going to go off to the side here. You don't have to write this down. You can cover your ears if you like the method we just did. You could do this if you like to stay consistent, where you're setting it equal to 0 right away. You can do that. Like on the top here, if you noticed, right away we set the denominator equal to 0 like this. So if you like to keep the same method, you can. What would I have to do to both sides to solve for x in this situation? I want to show you a quick method if you're pretty good with square rooting stuff. How would I get x alone? What do I got to do to both sides first? Yeah. So I get x squared equals 25. Does anyone know how to get rid of a squared? Think of what you did when you factored. What did we have to do? Yeah, someone said it. Square root. Well, what's the square root of 25? 5. The only thing you'd have to remember is that there's a plus and a minus. And here's why. If I have negative 5 squared, I'm still going to get 25. So you have to be able to include both of them. So those are the two routes you can go. You can factor or you can solve. It depends on who you are. Some people just like that fast method where you just solve for it. That's fine. All right, flip the page. We're only going to do pieces of the next couple pages here. We have 2 more pages, but... So we just did this for a reason. We learned about discontinuities, which make the bottom equal to 0. But there's 2 types of discontinuities when we are talking about the x's. We can have a hole. Remember I told you about the hole. Or I can have this thing called an asymptote where it never touches it. And we'll talk more about it tomorrow when we look at graphs. I'm actually going to cross this out for today because I really don't want to overwhelm you, but I still want to go a little bit further with what I just taught you. So first step. Oh, actually, let me teach you something first. A hole is called a removable. So with a highlighter, highlight removable. That means that when you're doing this solving part, you can cancel it, which is what you're doing. You're removing it from the situation. And it's going to approach some number. Whereas if you have an asymptote, it's going to approach one of the infinities. Hold on. One of the infinity signs. That's tomorrow. I'm not going to go into that today. So I put them side by side for a reason, so you can see the difference. Let's focus on what we always focus on, the denominator. What makes the bottom 0? Go ahead and solve for that. We just practiced that on the first page. So don't look at anything else. Just do what you already know I taught you. What makes the bottom 0? Go ahead and solve for that. What'd you get? 3. So x cannot be 3. Very good. I'm going to go down to this little space here so that we can talk about it a little bit more. Do you notice something about the numerator? Does it look like something we've been doing? Like for the bell ringer and things like that. Can I factor x squared minus 9? What does this become? Like the bell ringer. X, yeah,
X plus 3, X minus 3.
good. Okay, so that's why I said factoring with difference of two squares is one of the biggest things. I factored that, and that's what happened. Does something come out of the bottom? Is there something, and now let's just take it piece by piece. Highlight both the top and bottom so you know that they're different parts. Look at the bottom. Can I factor out a number? Is there a number that goes into both 4 and 12? What? Higher than 3?
Oh, no.
4.
4. Okay. Going way back to factoring. What's 4x divided by 4?
1.
X. 1x. Good. What's 12 divided by 4? 3. Okay. So all I did was I factored the top and the bottom. You are good at factoring. You just need to, sometimes what people do is they get really overwhelmed looking at this, but just take a second and like, okay, I'm just going to factor the top. I'm just going to factor the bottom. Do you notice something about the top and the bottom? They both have the 3. Take a look. Do you notice how this guy and this guy are the same? Well, then they cancel. Okay, so if you have something that cancels, you have what's called a hole. And that's what's new. That's the new part about today. If you have something that cancels on the top and bottom, you now created a hole in your graph. That's what you just figured out. Only if you see something that cancels. Think it's a removable discontinuity, so I'm removing it by canceling it out. Okay, so I'm going to have a hole at x equals 3. We're going to come back to this tomorrow, but I'm going to have a hole at 3, comma something. And we'll talk more about it tomorrow. I didn't want to overwhelm you, but I just want to tell you that if you cancel something, you have a hole. I'm going to put cancel here so you know. Whoa, and we're not moving. We got the right side. I'm trying to compare them with you guys. But what's nice about this is that we already did it. We already did the factoring, did we not? It's the same thing. I try to make it easy so that you can see the difference. This factors still into that 4 that comes on the outside. Sorry. X minus 3. Again, I'm just going through that really fast because we just did it. We just factored that. It's the same thing. Do you notice that nothing cancels? X minus 9 is not the same as x minus 3. That's what we call a vertical asymptote, which again, we'll talk more about tomorrow. But I wanted you to be able to establish the difference between the two. A hole, you can remove something by canceling it. An asymptote, I have nothing that cancels. And I will explain tomorrow what that actually means, but a hole versus a full line, okay? We'll talk more about that tomorrow. But the asymptote is going to be x equals your 0. Oh, I'm sorry, x equals your discontinuity, not your 0. I'm thinking of something else. Discontinuity. Which we had was 3 too, over there. I promise it's easier than that. I just want to show you some vocab. The next page is fast. We're only going to do 2 of them. And then I'll explain and do a problem with you on your homework. So flip it. If you ever get stuck on how to find a hole, this is going to be super important. We're going to come back to it tomorrow because we only did one piece of the hole. The holes are, in my opinion, the hardest topic of the chapter. If I were to say anything, is that today is probably the hardest day because you're learning something that's completely different. But once we jump in and we do more work with it tomorrow, you're actually going to be like, okay, it's not that bad. But this is completely new, so don't feel like, you know, I'm never going to learn this. It's completely new. You've never been taught this before. So we're going to do number 2 and number 3. Look at number 2. Where do your eyes go first? I want to find the discontinuities. Am I going to look at the numerator or the denominator? For discontinuities, for number 2. The denominator. What makes the bottom equal to 0? What's a positive 5? Do you see how we're doing the same thing over and over again? I just introduced you something a little bit different. Okay, so I got 5. X cannot be 5. The only step now, based off of what I taught you just now, hopefully, would this, for a prize, raise your hand, be a vertical asymptote or a hole, and why? Based off the page we just did. Yeah, who said that? Did you say that too? Why is it vertical? You're right.
Is it negative?
Not because the negative. Anyone know why it's a vertical asymptote versus a hole? This is your answer. You're right, it's vertical. What makes a hole? What has to happen for a hole to happen? Anyone? No. Oh, they just got lucky. So let me explain that, because you need to know this. A vertical asymptote. Is there anything that cancels? Is this exactly the same on the top as it is on the bottom? No, right? So nothing cancels. I'm going to put that for your notes. Nothing cancels, so that when you go back and you look, you know why we labeled it as vertical asymptote. We have one more and we're done. You haven't learned new math in about 3 weeks, so this is probably rough. I understand. I get it. Because it's been 3 weeks since you actually learned something new, but push through it, please. We got one more. Let's take a look here. Do you notice this guy? What can he be broken up into based off of what we did on the bell ringer and what we've been practicing for a while now? Yeah, I heard it.
What are you asking?
How can I factor x squared minus 25? Yeah, minus 5 and plus 5, right? So you have to be able to establish that you can factor that. Now, the next step. What makes the bottom 0 in blue? What's my discontinuity? What makes the bottom 0? A positive 5. Okay, so that's what I taught you on the first page, the discontinuity. The very last thing we're doing today, is it a hole or a vertical asymptote, and why? A hole, why? Yeah, look, right now. So this is like if you were to look now. Because I can do this, it becomes a hole. So because I canceled something, it's a hole. Because you're removing it from the problem. It's called a removable discontinuity. Okay? So again, I know this was rough. It's been a while since you've learned something.
That's it?
That's it. So the two things that you need to do in your homework is just this and tell me it's a hole. So I know that second page was rough, but it was kind of getting you used to the stuff. I want to do 2 of them with you. 1 through 6 are like 30 seconds. You're just telling me if it's yes or no. You can cross out number 2. Cross out number 2. Cross out 2. Cross out 2. You can cross out 2. It's front and back. Do not miss the back. The back's actually really easy. It's really straightforward and very easy. Okay, remember that the only thing, you can cross out 2, the only thing that rationals can't be, you have an exponent here and a radical. 2 of them have those. Which ones? Which ones have this and highlighted in yellow? Which ones have that? 1 and 2 are done for you or crossed out. But look at 3 through 6. Which ones look like that? What numbers? Yeah, 3. Because look at this guy. So circle him and put no. It's not rational. Because of that radical we just talked about. What other one looks like the other one? What one looks like 3x? Yeah, number 4. Because of this guy, it's a no. These ones are a yes because it doesn't have those things. So you already did 1 through 6. This is actually a really fast homework assignment. It looks long, but it's fast. So let's do another one. I just kind of did it for you, but remember, all you're doing is telling me what makes the denominator equal to 0. When you solve I'm just going to like write this out for the sake of time and help you out so that you can have something to look off of. You should get 3 when you do this 2 steps. So that's what you're going to put right here. That's where it's at. Good. So then the next part is what kind? A whole or a vertical asymptote? Do you see right here? There's nothing that cancels. So it's a vertical asymptote. So really the only 2 things you're doing is telling me what the discontinuity is, which is pretty easy, and if it's a whole or vertical asymptote. Okay, so you already almost are done with your homework. The back is multiple choice, and all it asks is for you to tell me what makes the bottom 0. You don't have to tell me if it's a vertical asymptote. Yeah. On the back, you don't even have to tell me if it's a vertical asymptote or not. You just have to tell me what the answer is. So I'll do one with you on the back too. All you're doing on the back is look, what makes what I highlighted equal to 0? Which one of these would make that 0? Yeah, -1. So this is your answer. Done. Okay, these back ones are just getting you used to setting the bottom equal to 0. But a lot of you can probably work backwards if you don't know. Just plug them in. Which one makes them 0?